Okay, so we are going to be talking. Let's take a slight change now from just our regular boring Java on desktops and on our websites and things like that. Let's talk about Java on mobile, and we have an awesome presenter here, Johan Vos, who is also a Java champion and many other accolades as well. Johan works for GlueCode, and GlueCode are doing some really interesting things with Java on mobile devices. So we're gonna have a good session here. The sponsor of this session is Zero Turnaround, and our participating jug is the Edinburgh Jug. So we'll say hello to them all in just a moment. Yeah, so Zero Turnaround have a couple of products here, XRebel Local and XRebel Hub. So we'll just do a very brief introduction to these. One of the things which we're trying to do is make sure people understand how they can performance test early and consider performance at all aspects of their pipeline or their application lifecycle. So here, rather than just wait for production before you can run your performance testing, there are certain things, not everything, but there are certain things you can run earlier in development and test from CI and as you're writing code, all the way up to your load stress tests before you jump into production. And Zero Turnaround provide two tools for this: XRebel Local, which is a developer tool, and XRebel Hub, which is a tool which can test for regressions between builds from CI all the way through to staging. So do check out that, and you can go to zeroturnaround.com for some more information on that. But for this session, you can join Slack. Actually, I believe the Slack link is out of date on the, I have no idea why that is, but it's out of date. So I'm going to update that during this session. But so in 10 minutes on the virtual jug, vjug.com, sorry, vjug24.com site, you'll be able to click on that link, the Slack icon, and you'll be able to join our Slack group. For Twitter, vJUG24 is the hashtag, so make sure you do join us on that. And also we have, make sure that when you're watching this video, if you click on the little settings cog on the bottom right of either your bed or if you're on YouTube Direct, and make sure you go up to the highest resolution you can. That'll give you the best viewing experience. So let me jump out of this. Stop sharing, and let's see who we've got. So we have there we have Henry Coles. We have the Edinburgh Jug. Hey everyone, how's things? I can see some familiar faces. I see Maurice there. Hey Maurice, good to see you. Okay, right. So we'll be taking questions from the Edinburgh Jug, just as we will the online user groups as well. So let me jump over to Johan. Johan, how are you doing?
Hi, Simon. I'm great, thanks.
Excellent, excellent. Sorry, I said GlueCode. It's not GlueCode, is it? It's Gluon.
It's Gluon, but I can imagine that you're confused because Amazon and Microsoft announced a partnership about AI, and in all their wisdom, they decided to call that partnership Gluon. Which is
okay, I think I'm just confused because I'm halfway through this ridiculous 24-hour virtual jug conference, but that's another distraction. So what are we going to be talking about in your session?
Today we will talk about Java on mobile and how to connect it to the enterprises. So we will show how you can extend your existing enterprise code and run it on mobile. That means iOS and Android.
Awesome, awesome. So over to you, and in your own time, please take control.
Okay. Let me find my presentation. Oh yeah, I don't have a green. I don't have a green wall. I was talking to Sebastian Dashner. I said I have a green screen, and the only thing I could come up was a Christmas tree, but that would be a bit.
So you've had an hour to paint that wall, but you didn't bother, huh?
Yeah, not enough time.
Great.
Okay. You see my slides?
Yeah, absolutely.
Okay. So this is about Java 9. I try to put the most important things in bold for the people that are too tired. Just remember Java 9 mobile apps backend cloud serverless. So, and that's a summary, but what we will show is that you can use Java 9, so the Java 9 that's just been released, and you can create mobile apps with Java 9, and the application code that you use is exactly the same as the application code that you would use to create desktop applications. So you don't need to learn a new language if you want to create mobile apps with Java. And that's actually surprising to many people. When I give presentations for JUGs or at conferences, I typically ask how many people do know that you can create Java apps and run them on mobile and upload them to the App Store and the Play Store. And many people are still surprised that it is possible, but it is possible, and it's also very easy. And the second thing is that, so those Java apps are nice, but what's also very interesting to existing Java developers is that if you have a Java backend or cloud system that's running your code, you can easily connect that with your Java mobile application. And recently we also started to integrate serverless functions with Java mobile applications, and that opens a completely new world of opportunities. So I hope we can spend a few minutes on that, because I'm pretty excited about that. So what is the context? Today there are many enterprises that have software components written in, well, for their backend applications. And if they are smart, they wrote these software components in Java. And they typically expose this backend functionality via web frontends. But today, those companies are faced with increasing demand from users and employees and partners and so on, who want to access that same enterprise functionality not only via web frontends, but also via mobile devices. And then panic starts, because the IT department typically has excellent Java developers. And those Java developers, they focus on Java. They don't do, at least not as a core business, iOS or Android, because that requires different skills. So if they want to write mobile apps, well, they can use mobile web apps and run them in a tiny browser window on a phone. But that requires different skills as well. And let's face it, that sucks. So as a consequence, the mobile app development is often outsourced to a different team. So it's a completely new development. And the mobile development and the web development, they tend to diverge. So it's the enterprise developers, they keep on working on the Java backend, and the mobile developers, they work on their own systems. And one of the big consequences is, first of all, it's very unproductive if teams are not communicating with each other. And second, the security is a big issue, because in many cases, the mobile developers, they want all ports to be open, and they want to have access to all enterprise functionality. And that's, of course, not what enterprise developers want to hear. So that's, for many companies, a big disaster. But we have some good news. So first of all, as we said, spoiler in the beginning, you can use your existing Java skills and use them to create mobile apps. So you don't need to learn new languages, or you don't need to create a new team if you need to create a mobile app. And second, you can easily couple those mobile apps with backend and cloud systems in a secure way. They are decoupled, each with their own life cycle, but still very much integrated with each other. So I will now briefly talk about Java on mobile, and then I will talk a bit more about how to integrate it with backend systems. So Java is, for a long time already, the leading language for enterprise software development. But on mobile, it has not been very successful in the long history, because of very different reasons. There were no standards. You could not run Java applications on devices that had J2ME with KVM, CVM. So it was very, very hard. But not going into detail about the different problems. But today, all these problems are solved, and it is very well possible to create Java applications using the Java APIs that you know, Java 9 even, and you can upload them to the App Store and the Play Store. So that's very good, because you don't have to do the delivery of those apps yourself anymore. So thanks to the concept of stores, your applications can easily be delivered to the end user devices. And that is what was a huge problem in the past. I worked with PDAs and with embedded devices and the very early smartphones. But it was always such a big problem to get a Java app and then run it on all those devices with the different form factors, and so without the uniform deployment mechanism. So Java, the Java language on the enterprise is exactly the same Java language that you can use on mobile. And that creates huge opportunities, of course, for existing Java developers. Keep in mind, though, that resources are different on mobile as an enterprise. So before you start running your WebSphere application on a mobile phone, think about well, the limited resources there. JavaFX is the user interface language, and JavaFX provides the user interface APIs for Java. So it is the standard for Java UI applications. And it is very applicable for mobile development. I will briefly talk about it later, but I will also briefly talk about it now. So using JavaFX, the user interface is directly rendered on top of the frame buffer of the device. It's using hardware acceleration. It's leveraging the GPU, so it is very performant for mobile, because mobile devices have a powerful GPU. It's not rendered in WebView, but directly on top of the frame buffer. So when we say that Java works on mobile devices, we typically got a number of questions. So first of all, the number one question is, yes, but Apple does not allow dynamic code on iOS devices. That is true. And therefore, we don't run the Java bytecode on the device. But our tools, and I will explain them in a minute, include an AOT compiler that will compile your Java bytecode and all the dependent code ahead of time into native code, and then it will bundle it with everything that's needed to create an iOS application. So there's no Java runtime on the iOS device, although you're executing the Java bytecode. Obviously, you don't have to install Java, the JDK or the JRE on an iOS or an Android device, but that's of course the advantage of the app stores. Everything is bundled in an application. It is not rendered in a web view. The Java FX solution, as I said, leverages hardware acceleration to directly render the Java FX controls on top of the in the frame buffer. So it's not using web view. It's also not using the native iOS controls or the native Android controls. It is using the native Java FX controls. It is very cross-platform because you write the code once and you run it on desktop, you test it on desktop, and you improve it on desktop, and then you typically run it on the simulator or on the real devices. And if you use the Glue on Mobile library, you can use the JavaFX controls, but on top of that, Glue on Mobile contains a component called Glisten, which provides a material design look and feel. So that makes your applications more mobile looking. Still, it is the same Java code that you use. So you have this on desktop as well. And if demo gods are productive today, then I will near the end I will show an example. I say near the end because if I screw up, then at least the presentation worked. People often say, yeah, but iOS and Android look slightly differently. Well, slightly or completely different. Well, yeah, that is true. Now, some users, they prefer cross-branding across iOS and Android. They prefer their brand to be central, while others want the application to be more iOS-looking or Android-looking. And that is what we solve by using different CSS style sheets for Android and iOS, and even between tablets and phones. And that is a great thing about JavaFX. You can have exactly the same code, but different style sheets for different deployments. So, for example, on Android, you would use a different style sheet than on iOS. Don't worry too much about it. The tools will make sure that everything is deployed in a bundle. Most of what we're doing with Gluon is open source, especially the client components. The core principle of what we develop is that it should be very easy for Java developers to create applications without going through the hassle of paying for licenses and so. We try to make everything free for developers. Once you're using something in a commercial application, especially if you connect it to the backend, there we have Glue on CloudLink, which has a free trial as well, but which has a freemium model to connect your applications to backend systems. You don't have to use it if you want. You don't have to use Glue on mobile. You're perfectly fine if you just use the Glue on plugin, which is free, and you can start creating cross-mobile applications in Java. So there's no catch here. You can really create mobile apps without being a Glue on customer. Of course, I don't want to scare away customers, so we offer added value. So if we look at the stack from top to down, from what's it called, bottom and then up, then the lowest thing that we deal with is the virtual machine, because we're running Java bytecode, or at least transposed Java bytecode on a device. On Android, Android is more or less Java. It is a bit Java 6, a bit Java 7, a bit Java 8. And at this moment, it's enough Java to get most of the apps running on it. iOS is different because it has no Java. Until recently, until a few weeks ago, we were using an AOT compiler that was based on Harmony. Harmony is an implementation from Apache for the Java core APIs. But it's discontinued, and it got stuck somewhere between Java 6 and Java 7. So we realized that we needed a new approach, and at Java 1 this year, a couple of weeks ago, we announced Glue on VM, which is based on OpenJDK 9. There were a few sessions already today about OpenJDK, so people that are awake for a long time already will be familiar with it. But basically, OpenJDK is the place where the Java core specification and implementations are being developed. So by basing the Java mobile solution on OpenJDK, we guarantee that all Java classes that you use for mobile are exactly the same Java classes that you use for desktop. So it's not that we have a fork or a virtual machine that implements parts of the Java base module. No, we really have the full OpenJDK 9 repository that we are using on mobile. There is a project initiated by Oracle called OpenJDK Mobile, and that provides ports of OpenJDK to ARM architectures for iOS and Android. The performance of this VM is boosted because, well, as I said, we don't execute bytecode on the VM because it's not allowed, and we had to use an ahead-of-time compiler. As a consequence, we're running native code, so we are at the same order of magnitude as native applications. So the virtual machine and the related components that together form Glue on VM is based on Java 9 and Java FX 9, and it's available on mobile devices. We will make it available for Android as well. At this moment, the focus is on iOS because, well, on Android you have something that mostly work. You can use lambdas, you can use streams. So therefore, our focus was on iOS. Developer Preview 1 was released at Java 1, and we now have Developer Preview 2 almost ready. It works on the iPhone simulator and on iPhone devices, and it will work on Android later as well. But it's important to mention that we're making this open source because, well, OpenJDK itself is open source, and I think it's in the good spirit of the Java community to collaborate wherever possible. And the virtual machine is the heart of the Java platform. So many companies and many very smart people are working on this. and it would be stupid not to try to collaborate and leverage the work. So we are working as much as we can with OpenJDK, and we really want the wider Java community to work with Glue on VM as well. So the more we can share, the better. There's a link here that you can follow to sign up for beta access to the developer preview. The only thing we ask is, well, give us feedback and try it and make it better. So the virtual machine and the AOT contain a number of components. I'm not going into detail. This schema is very much a simplification of reality. You see that there's lots of code, application code, virtual machine code that's all compiled to native libraries or class libraries. Then the AOT compiler is compiling the class libraries into object files. And then the Glue on mobile tools will produce the native applications. They will launch it on the simulator or launch it on devices. So that is pretty complex, but what does developer see? It's only an IDE plugin, that's all. Everything else happens under the hood. So here's a screenshot of a screen. So it's a screenshot of an IDE, NetBeans in this case, which has a Glue on mobile plugin where you use that to create code. And then if you put your glasses on, you can see that there's a task menu which has, for example, launch iOS device. If you click that task and you have an iPhone connected to your MacBook, then your code will be executed on that mobile device. And it is as simple as that, so you don't need to install other things. Unfortunately, at this moment, you can only create iOS applications if you have a Mac, because under the hood, we rely on Xcode, which is not available for Linux, but we're working on that. So briefly, what happens under the hood? The IDE plugin, so that is the only thing that you have to download. It exists for NetBeans, IntelliJ, and Eclipse. If you search for Glue on, then you will find this plugin and you install it. It will invoke the JavaVX mobile plugin, which is another open source component. It's a Gradle-based plugin. Don't worry if you don't have a Gradle, the Glue on plugin will install it for you, or at least ask to install it. And this JavaVX mobile plugin will do a number of things. It will compile your application-specific code and all the dependencies, including the native code. It will bundle it with the dependencies and resources, with the core classes from OpenJDK, and with the virtual machine, which is called Boson. And it will combine everything and then run the resulting application on the connected iOS device, on a simulator, or it will produce an app that you can then upload to the app stores. So the Java core classes, as I said, they come from OpenJDK. And I can't stress this enough, that this is exactly the same code as OpenJDK. Well, more or less exact. Rounded, it's 100%. But at this moment, we use a snapshot of OpenJDK in June. So we have to update that to the very latest. But it's that's well, just a build detail. The native code for these Java core classes also comes from OpenJDK, from the OpenJDK Mobile project. And we have support for most of the modules. I mentioned a few here. Especially, I want to emphasize that the Java security APIs are working, not only the security APIs in the Java base, but also the more fine-grained security APIs for PKI infrastructure and so on. And that is very important for the rest of the story, because security is very important in mobile applications. And Java is built with security as one of the fundamental cornerstones. And the fact that you can use the Java security APIs, or that you can use libraries that depend on the Java security, gives you a huge advantage over other platforms and languages that that don't take security that serious as Java does. So security is really one of the key differentiators for Java being a first-class citizen on mobile. The AOT compiler is just compiling the Java bytecode into native code using an intermediate format generated by LLVM, and it will also take care of code that would otherwise require dynamic code to be generated on the device. The important thing here is that whatever we can do at compile time, we should do it at compile time. If you have to wait one more minute, well, it's exaggerate. If you have to spend 5 seconds with each deployment cycle waiting for some optimization, but if those 5 seconds can reduce startup time for the end user with 5 milliseconds, then that is definitely a big gain. So trying to reduce the startup time is very important for mobile apps. The build tools are the ones that combine everything. So those are the ones that are called from the JFX mobile plugin, and they will build everything into a mobile app that you can then run on the device or upload to the stores. I'm now until now I was talking about Java 9. I want to emphasize that the solution that we have working for a number of years now it's also working for Java 8, 7, and below. So if you're not yet using Java 9, you can still use the Gluon plugin, because what I'm talking here is about what we announced at Java 1, and it is well, we want to make it clear that this is a project that is very much alive. So it's not something that we created once. No, by aligning us with the new Java 9 developments, we show that this is really future-proof. But if you're not using Java 9 yet, don't worry. I mean, yes, worry, because Java 9 is really great, but not everyone is allowed to use Java 9 in every project. So if you're using Java 8, 7, that's perfectly fine. Your application will work, of course, with the existing tools. So on top of the Java virtual machine, we can now execute a bytecode, but we still need to create a user interface, and therefore JavaFX, being the cross-platform Java user interface language, comes in very handy. It allows you to write the application on desktop, which is still a bit more convenient than writing it and testing it on mobile. On average, a deploy cycle on mobile takes 30 seconds till 1 minute. So that's okay. But on desktop, it takes 5 seconds, for example. So it has advantages. The JavaX is a modern UI toolkit which leverages hardware acceleration and which will use OpenGL ES to render on Android and iOS. At least at this moment, there might be ports to other systems, like, for example, Vulkan. But it is also something that that's very community-driven. So there are many open source and commercial projects around JavaFX. The ecosystem is really very, very big here. So going one layer up in the stack, with JavaFX, it is possible to create cross-platform mobile applications. And you can have the JavaFX controls on iOS and Android. With Gluon Mobile, we have a number of libraries that make it easier to call into the mobile development specific. For example, we have support for, well, if you want to call REST interfaces, we have Gluon Connect, which is a completely open source library that allows you to connect to REST interfaces. Charm Down is another open source library which allows you to connect to the device-specific things like accelerometer, GPS, camera, contact book, and so that is functionality that is typically available on iOS and Android, but with a different API. And in Charm Down, we provide a single API that is then mapped to the native implementation on Android or iOS. But you don't need to know the details about the native implementation. You just write the cross-platform code, and under the hood, again, there happens a lot under the hood. It's a big hat. It is mapped to to the native implementation. The other thing that Gluon Mobile provides is Glisten, which provides, on top of JavaFX, additional controls, additional Java controls that are more mobile oriented, like, for example, the floating action button that you can see on the right hand side, or the typical search icons and the hamburger icon, the navigation drawer, and so and the number and a bunch of icons. So that is something typically for mobile development. So we created those components, and we also styled the existing Java components using style sheets to be more material design looking. So we adopt the material design guidelines from Google, and as a consequence, your application looks really like a mobile app. So that is the mobile part so far. If we now go talking a bit more about how can you connect your mobile application to existing or new backend applications, that's where we have Gluon CloudLink for, and that allows for an easy integration of your Java mobile app with your Java backend app. Well, you can also integrate a non-Java mobile app with a non-Java backend app, but it is, of course, if you leverage the same platform and the same language end-to-end, this is huge productivity gain, and you can use the same skills on backend and mobile. So I think it's an advantage, but we support other backends as well, of course. Security, decoupling, and integration are very important when talking about connecting mobile apps to backend apps. For example, security. If you want your mobile app project to fail, the best thing you can do is to directly connect or write a mobile application connected to a backend application that does some financial things, and that requires a key and a secret in order to be accessed. And if you put a key and a secret in a mobile application, that's a huge disaster, of course, because well, the mobile application can, you don't even have to sniff the network. You just download the mobile application. It's very easy to reverse engineer, especially Android applications. And the key and the secret of your backend application is exposed. And that would be a disaster, because typically that gives you access not only to mobile functionality, but also to other backend functionality. So that is something that that you don't want. And that is one of the reasons why there's typically lots of friction between mobile teams and enterprise teams, because the mobile teams want to access the functionality in the easiest way, and the backend teams want not to open their functionality to the entire world, because that is what you have to do. The mobile app runs on mobile devices, and they can have virtually everything, virtually all IP addresses. So you really have to open it for the whole world if you want to use this approach. So the better approach would be to have some software in the middle, like Gluon CloudLink, which is a SaaS solution that that will be the only component in the whole setup that will then talk to your backend application, and it is running on a server. So the mobile applications do not talk to the backend application directly. They talk to Gluon CloudLink, and they say that, for example, I want to buy this ticket, and I want to supply this and this parameters. And then Gluon CloudLink can look it up and say, okay, yes, this functionality that you want is indeed available. And in order to do this, I have to call this backend functionality This is a REST function. These are the parameters, and that is something that you can configure using a web interface on gluon.io. And then the key and the secrets that are needed to talk to the backend application can be retrieved by Gluon CloudLink because they are entered by the administrator in Gluon CloudLink. So not in the mobile application, but in the intermediate layer. So the very sensitive security information is not exposed to mobile applications. So mobile applications can talk to Gluon CloudLink, but this component will then decide what to do with the call. Should I call the backend application, or should I return a cached result, or should I just deny the request because this device is asking too much questions at the same moment? But if it decides, yes, this is a valid question, it will then use the key and the secret to call the backend application. So that makes your mobile application and the backend application together much more secure. And you can use that to connect, for example, to a Java EE backend application, where you can have a message of the day application, where if you set the message of the day, you can also go the other way around, where the Java, the backend application talks to Gluon CloudLink and tells, hey, some information that might be useful for mobile apps can be changed or has been changed now. And Gluon CloudLink will then inform all the connected mobile applications about the change. We're using under the hood, again under the hood, we're using SSE or WebSockets for realizing this. So that allows real-time communication between backends and mobile apps. So that's pretty exciting, I think. So there are much more things that you can do with Gluon CloudLink, but we don't have the time to go into details, but you can go to the gluonhq.com website, or you can go to Gluon.io and apply for access to Gluon CloudLink. We have a free trial. It's fully functional, but in essence, Gluon CloudLink is a SaaS solution, so it's currently hosted at Amazon EC2, and the mobile clients connect to this server. It's actually a set of microservices running behind load balancers and so. And every different application manages its own data. So it is multi-tenant, and the mobile clients connect to it, and CloudLink connects to the enterprise and cloud systems in a secure way. It provides also typical mobile functionality. For example, if you want to send push notifications to only Android phones with that are, for example, in France, then you can do that as well via Gluon CloudLink. It is by default, we have the SaaS solution deployed on Amazon EC2, but it can also be deployed on-premise on your own hardware, and that's something that we see more, it's becoming more popular now. You can deploy it in your own dedicated cloud environment, for example, using as a Pivotal Cloud Foundry service broker, but you can also, for example, we have support for the Oracle Cloud. So if you have existing infrastructure, or if you want to become an Oracle Cloud customer, you can easily deploy Gluon CloudLink inside the Oracle Cloud infrastructure. And doing so, you have your own personal copy of Gluon CloudLink. So you have all the functionality, but the data, your data is not shared with others. Not that the data is shared with others in the public SaaS solution, but it is for many companies, it is still a bit sensitive to realize that they're actually sharing the same database with other companies. So therefore, the on-premise solutions are often on-premise solutions, and in the virtual cloud solutions are often very popular. Remote functions is that's the thing about Gluon CloudLink that I want to emphasize a bit today in the last part of this presentation. So Gluon CloudLink can communicate with cloud components or enterprise components in a number of ways. you can do data synchronization by using an SDK. So we provide SDKs for doing REST calls, for doing Java. We have a Java EE SDK and a Spring SDK, and those allow you to synchronize data from your backend application with Glue on CloudLink. With Glue on Mobile, because it uses Glue on Connect, you can synchronize the same data between the mobile and CloudLink. So that allows you to have an end-to-end path. But there's another thing which we call the function builder, and that allows you to map a remote function on the client to an external resource. And a function created by the mobile client can contain a number of parameters, and it can, when it's invoked from the client will ask CloudLink, please give me the result of this function. The function on Glue on CloudLink can call a REST service, or it can call a serverless function running in a serverless environment. Different security protocols are supported, and you can also return mock values. And this is actually very easy for the decoupling of the backend and the front end, because you can send a mock value while you're doing while you're still developing your backend, and you can send different values if you're in a staging environment or a testing environment or a production environment. So that is very very useful, and I think one of the best things to show why this is useful is suppose that, and this is a real world example that I think we blogged about it today. If you come to the DevOps conference in a few weeks in Belgium, the mobile scheduler for DevOps is created with Java on mobile. So that's using the Glue mobile framework. And in order to retrieve the schedule, a number of REST calls can be made to the DevOps backend. First, you get the number of, you need to ask which days is the conference, and then for each day you will need to get a session. So you have, if you want to do this on mobile, you need to write some boilerplate code to keep track of, okay, I already asked for those days, and these days are still coming, and so I can now visualize them. But if you use a function, you make one simple request, and then Glue on CloudLink. If you supply the function to Glue on CloudLink, it will execute that function. It can be on AWS Lambda, or it can be on an Event Project server. Event Project is the new serverless framework, open source, created by Oracle and released a few weeks ago at Java 1. And that function will then perform the different requests. One of the big advantages of this is that if something changes in the backend, you can change your function, but your mobile application stays the same. Suppose that there's a big security hole in the backend, and the invocations need to change immediately. For example, they need an additional parameter. You can change that in your function at the same moment that the backend is fixed. If you had to change the mobile application, then it means that would mean that you have to recompile the application, upload it to the App Store and the Play Store, and hope that Google and Apple will approve it soon. But it might take days, or even if it's rejected, it might take weeks. And that's, of course, not acceptable with mobile apps that have security holes. So first, I'll go to the conclusions, and then I will show briefly show some of the code for this. So with Glue on VM, we have Java 9 on mobile. Keep in mind that we already had Java 8 on mobile, so that's already covered. It's based on OpenJDK, so it's the standard Java. It's leveraging Java FX, and Glue on Mobile adds Slick UI components to it. It is open source, so we hope others contribute to it. Glue on CloudLink allows you to connect the mobile apps with enterprise components. Security is key there, and with function builders, it becomes possible to create to call external functionality, or to use the serverless frameworks that are emerging. So I'll now try to switch to NetBeans. So if that fails, it was nice talking to you, and I hope to see you on the next occasion. Still here. So this is the NetBeans where I have a project already. For example, the fast demo app is a mobile project which contains, it's actually very easy to create it. If you go to NetBeans, see, I said I should not do some live coding, but I can't resist. So you go to Gluon, you create a single view project, vJUG demo, you click on finish, and now the project is being created for us with some demo code. And if you want to see the demo code, don't worry about warnings. We just click on run, and so this is the basic application that's been created. I now run it on desktop, but if you had a look at the tasks here, you could see iOS, launch iOS device, launch iPad simulator. So that would then launch the application on a mobile device. So it's as easy as that to create a mobile application, and the source code that's created by the template consists of two classes. First of all, the main class, the vJUG demo, which says I have one view, which is the home view, which is what you could see, and then the details about the view is we want to have a label which says Hello JavaFX World and a button Change the World. And if you click the label, Hello JavaFX World will change in Hello JavaFX Universe. So this is actually what you can see here. A button Change the World, you click on it, and it mentions Hello JavaFX Universe. So that is a basic Java mobile application. So you can add functions, and actually I'm running out of time, so I will show the function that I created here. But creating a function is as easy as going to the Gluon menu and click on Add Gluon Function. Oh, by the way, this plugin is not being released yet. We started recently, but we will release it soon. If you create a function, again, a function template is created, and it's called, well, you provide the name. In this case, it's event demo function. If you provided your Gluon CloudLink credentials, this is immediately uploaded to gluon.io. Hey, that's you. Here is the gluon.io dashboard, which allows you to manage Gluon CloudLink. One of the things is API management, and we see that for this application, we have one function with the name event demo function. And if I click on test, I will invoke this function. So Gluon CloudLink will start a container and will execute your function on the server in a serverless environment. So yeah, the name is really cool, serverless. So you see that the output of this function is random number is 19. And that is actually exactly what the function is supposed to do. Well, not exactly the 19, that could have been 20 or 21 as well. But so this function, which we created using our IDE, is uploaded to CloudLink and executed in the cloud. Now, the next step is, of course, we want to use this function in a mobile application. Well, we have the basic view from what we showed before. If we go to with NetBeans, for example, let me quickly rename this because I already had it. We go to insert code, and we see generate Gluon function, and then NetBeans will it knows that I have one function, and it will generate some code that will when executed on a mobile device will call Gluon CloudLink and will execute the function. So the code for this is very simple. So I can remove the don't, but I don't have to remove it. It's calling the remote function builder, which is automatically imported and which is part of Gluon Mobile, and it will tell it I want to create a remote function called event demo function, and then I will simply call this function, and I provide a string. I provide one value, a string, but our function is not doing anything with the parameters. But you can provide any number of parameters. The result of this invocation is a Gluon observable object, which extends the Java FX observable object. And the Java FX observable object is very cool because you can bind that to a UI component. So in the code that shows the user interface, we have this label hello Java FX world. But if the user clicks on the change the world button, instead of changing the text in hello Java FX universe, we will now change it into the value that we get from the event demo function. We actually bind the text property of the label to the value that's returned by the demo function. So if we run this application, which is exactly the same as the one you saw before, apart from that we now have this function, and we click on change the world, you see that we are using getting the result back from the serverless function, which is executed on the server. So if you look at how few code is required to call this function, and of course the demo function is very easy now as well, but this can be very complex. But you want this complex code not to be part of your mobile code, because that is error prone, and then you have to maintain it, and if there are bugs, you have to re-release your code. You want to deploy this on a server or in a serverless environment. I still have issues with the name serverless. So we did this actually with the MyDevOps mobile application. We introduced this, and if all goes well, I have the commit message for before and after. Before we were using functions, and after. So left is before, and you could see how much code that we had on the client for dealing with getting the functions, and look at the right how easy it became. So we have much less code on the client. Actually, the only relevant thing is here that we create a remote function, same way as we described it before. Here we have to give a number of parameters, and we return the result as a list. So doing so, you save lots of lines of code in your mobile application. And that gives me personally a much more confident feeling, because if something is broken on a mobile client, it's out there on millions of devices, hopefully. And it's very hard to correct those devices, because you don't know when users will upgrade. But if you have that code on your function, which you can update every second, then you're much more in control. So with that, I think I can conclude my presentation, and I guess I'm open for questions.
Okay, awesome. So we're going to jump straight across to the Edinburgh Jug first, see if there's any questions live from there, and then we'll take, we've got a couple already. Sorry, hang on, my mic is on this side. We're going to jump across to the Edinburgh Jug first, see if there's any questions live, and then I know there's a couple in Slack as well, so we'll jump to that straight after. So, calling Edinburgh Jug. Any questions in the room?
Hello, can you hear me?
We can, loud and clear, thank you.
Nice. So I have a couple of questions. So first, I understood that Gluon uses Java FX for UI. So I'm wondering, how does the performance compare to native? And then I wanted to know if the Gluon dependencies make the apps larger than native apps, and whether there's a full range of open source libraries I can use with Gluon, or are there some limitations? Thank you. Okay,
I can answer. I'll try to answer them quickly, because I saw that we have some questions on Slack as well. The performance of JavaFX compared to native. So as I said, JavaFX uses hardware acceleration to do the rendering. So the rendering is done using the GPU, and therefore, in theory, performance should be similar than native. We didn't spend much work yet on optimization. It is definitely something that we try to keep improving. But for the most of the applications that are out there, the performance is really good. So it's because it is native. It is actually the same as iOS. The business logic is executed in native, and the UI is rendered on top of OpenGL ES. Having said that, it is it is easy to create a very performant application in Java and JavaFX by extension, it is also easy to create a very slow and unperformant application in Java and JavaFX by extension. But I've done performance analysis of a number of apps, and in 99.9% of the cases, the performance issue was app-related. And in JavaFX, that typically means that processing is done on the JavaFX application thread where it should have been done in a background thread. So with the Gluon mobile tools, we try to make it harder to make those pattern failures. But it is possible. But if you do it the right way, then performance is really more or less similar. So are these apps larger than native apps? On Android, not really. On iOS, slightly, because we bundle the virtual machine. But in general, the overhead created by bundling the virtual machine is less compared to the number of devices, number of resource and media files that are in the typical apps. So that is the second question. The third, limitations to open source libraries? No, there are no limitations. So a number of the Gluon libraries are open source, so you can use them for free. If there are other open source components that you're using and that are not working well on our solutions, let us know, because that is our #1 requirement. We are a developer-based company, and we really want developers to be able to work with our tools. We are a business as well, so we provide commercial tools, and we really want to show that there's a business value in this, but we especially want to make sure that developers can work with the tools.
Okay, so we've got a couple of, I think they're probably pretty quick questions in Slack. One is there any relation between Graal VM and from Oracle and Gluon VM?
We're for the AOT, we're looking into using parts of Graal. Graal already support executing LLVM bitcode, but not yet generating LLVM bitcode. But we're in close contact with the Oracle labs that are working with this. So we already use the virtual machine and the core classes, and it's work in progress. But we definitely try to align with Carl. Okay, and question from Daniel. Gluon, when will the ordinary user be able to use Gluon VM? Version 8.60.9 of JavaFX ports is still not using it. Is that correct? That is correct. So Gluon VM, so X860 and below are still using the old approach. Gluon VM starts with Java 9, but we already have JavaFX ports 9 in a beta out. So that's also an open source project, and the repository is there, and we're using that. So 8.60.9 will probably not use Gluon VM, but 9 will use Gluon VM. Okay, and we can probably take another question from Edinburgh if there's time and if there's a question.
Hi, you're saying that the Gluon link would provide a more secure communication. You wouldn't expose the key and secret directly. Can you elaborate on that? Yes. So if your backend you have a REST API which requires some authentication. Let's say it's just basic HTTP basic authentication. So you need to provide a key value or a name password if you want to call that that REST endpoint. Now, if you call that directly from a mobile client, then it means that the mobile client somehow needs to have this key secret or username password. So if you bake it in the mobile client, everyone can detect it. But if you have it in Gluon CloudLink, then you just configure it using the user interface that I quickly showed, and you can provide the credentials there, and they don't leave Gluon CloudLink. So the mobile app will then call Gluon CloudLink. It uses a OAuth for doing this, so it's already using some authentication, and then Gluon CloudLink can decide to make the call
to the external resource, but it will do that on behalf of the mobile client, and it's not going to share the credentials with the mobile client. So I think in the Gluon.io, in the API management, authentication is a separate tab, and if you you can create well, different different authentication schemes, and you can create different authentication security mechanisms.
Okay, so that we're pretty much a minute away from the next session. So we probably have maybe 30 to 40 seconds if people want to take a break. But in the remaining time, I'll just say a massive thank you to Johan. There's some, you know, considering what else there is available on Android platform or iOS, Gluon has provided a massive leap forward for Java on mobile devices, and let's not forget, Java was originally designed for a mobile device, so it's great to see the strides forwards that have been taken, led by Gluon. So yeah, do support Johan and check out what's happening at Gluon. I'm sure it's very, very valuable to many people. Also, a massive thank you to vJUG. You're obviously welcome to stay on if you still have the room and you're willing. We have. Did someone say Kubernetes? I think Ray just joined. Hey Ray, how's it going?
Hey Simon, good. How are you?
Awesome, good, thank you. So we'll just say, yeah, massive thank you to Johan, massive thank you to vJUG, and we'll be starting our next session. Oh, actually, it's 10 o'clock here already, so let's start our next session. So yeah, thank you very much, everyone.
Thanks. Bye.
Bye.